This is recording for Edexcel Further Pure 1. Coordinate Systems 1, the Parabola and Rectangular Hyperbola. This is section 1.5 where we're looking at problems involving the parabola. Well, here's a typical example that you might be faced with. I just want to work through it bit by bit, but beforehand let's just have a quick look at the sort of questions that were being asked. So this is a multi-part question, and it says that we have a parabola C, so the diagram shows C here, and we're told the parametric equations of C. It says we've got a point P here with coordinates 4 for the y coordinate, so it's something 4, and the focus down here. And we're asked to find the coordinates of P and S, or the x-coordinate of P. Now that's going to involve us in using the equations, the parametric equations. Remember that for a parabola we've got standard parametric equations that we can look up from our tables. Once we've done that, then the question asks us to find the equation of L. This is a straight line through PS. And then to look at where L meets the parabola again at Q, and then to calculate the midpoint M of the line from P to Q. Well, in part A of the question then, we're asked to find the x-coordinate of P. We know that the y-coordinate is 4, and we can use the fact that y is equal to 2t to show us that 4 being equal to 2t means that t is equal to 2. Therefore, we can say that once we've got t equal to 2, x being equal to t squared means that x is equal to 4. So that we have p is at 4, 4. We know that x is equal to at squared, and therefore this means that a must be equal to 1. But once we've got a equal to 1, that means that the focus, which is at a0, must be at 1, 0. That's neatly typed out there for you, so if you'd like to pause the video you can have another look through that before you move on to the next part of the question. Then that next part of the question asks us to find the equation of the line L which passes through P and S. So this is now just standard straight line equation work. Well, one way we can do it is work out the gradient of the line from P to S, and that obviously height there is 4 and this distance here is 3, so the gradient is equal to 4 over 3, and therefore the equation, we have y minus y1, so that's y. I'm going to use S for my y1 point, so y minus 0 equals gradient multiplied by x minus 1. So that's x minus x1 for this point here. And if you rearrange that, you will get that 4x minus 3y minus 4 equals 0. So here again, written out for you, so you can pause the video at this stage and have another look through that. The alternative to working with the gradient and this equation here, y minus y1 equals gradient times x minus x1, would be to use the equation y minus y1 over x minus x1 is equal to y minus y2 over x minus x2. In other words, using the 2 points that we know, P and S. And that would give you exactly the same equation here for L. So either of those methods is fine. The next part of the question says calculate the point at which the line again meets the curve C. In other words, work out the coordinates of Q on our diagram there. So we know that we have an equation of the line L is 4x minus 3y minus 4 equal to 0. And C, well, its standard equation is y squared is equal to 4ax. But we have already calculated that a is equal to 1, and therefore C has equation y squared is equal to 4x. So we can substitute 4x being equal to y squared into this equation here. So we're substituting one equation to the other. So these two equations give us that y squared minus 3y minus 4 is equal to 0, where the two lines intersect. This factorizes into y minus 4 and y plus 1 equal to 0, which gives us two values of y. One of them is y is equal to 4, but of course that's up here at P. So it's the other one that we want, which is y plus 1 is equal to 0, and therefore we can say that at Q, y is equal to negative 1. And once we've got y as negative 1, simple substitution tells us that x must be equal to 1/4, 0.25. So again, you pause this if you wish to look through that and make sure that you understand exactly what's going on there. The final part of the question is asking for us to find the coordinates of M, which is the midpoint between P and Q. Well, the midpoint is very easy to do, isn't it? You simply add together the values of the coordinates and divide by 2. So there it is, x is equal to 2.125 and y is equal to 1.5. So that completes this first example, and you see it was a multi-stage problem, each of which follows on from the last one, which is pretty standard for the questions at this sort of level. The second example I want to look at is actually a proof. It's a proof of a fact that we've already met, the idea that the distance between a point on a parabola and the focus, so this distance PS, is equal to the distance from the directrix x. So we're going to prove px is equal to ps. Now you don't actually need to know this proof for AS level, but it's not difficult, so worthwhile looking at just to see how it's done. It's pretty standard actually. PS we can calculate quite easily by looking at Pythagoras' theorem. So we can get this height here, which is equal to 2AT, and this distance here, well, because A is the x-coordinate of S, then this distance here must be AT squared, which is the x-coordinate of P, minus A. So then we can use Pythagoras' theorem to work out PS squared. If we look at the top of the diagram, P we know is at AT squared, so that's that distance AT squared, and X is on the directrix, so this little distance here is A, because the directrix has got equation X equals minus A. So that PX is equal to a plus at squared. And so we can work out px squared. Let's look at that then on the next diagram. So what we had then was px squared was equal to a plus at squared all squared. And using Pythagoras' theorem, ps squared is equal to, we've got the y value, which is 2at, and then the x value is at squared minus a, so it would be that squared, and then plus 2at all squared. So here we have written out ps squared here, at squared minus a squared plus 2at squared. And you can work that out, follow through the algebra, pause the video, and you'll see that we get at squared plus a all squared. But of course that was our value for px squared. And therefore we've got that ps squared is equal to px squared and px equals ps. Right, remember that what I said was that that proof is not one which is required. However, the result that px equals ps definitely is. You should be very familiar with this idea that the focal distance of a point is equal to its distance from the directrix. That concludes this video. In the next video we'll be looking at Cartesian parametric equations for the rectangular hyperbola. So we're going to be switching away from parabola to rectangular hyperbola.